All right. So as mentioned, I'm Kevin. I'm an engineer at SendGrid, now a Twilio company, and I'll just jump straight into talking about forking standard library JSON. So why would you want to do this? The Go1 compatibility guarantee makes our lives a lot easier, but it can sometimes also get in the way of important aspects of app development. For example, to work around a lot of the limitations in standard library JSON, you often have to write custom marshallers or unmarshallers. This can be error-prone, especially when you're doing something as simple as just trying to get zero-valued times to not be output when you have omit empty. We can make a fork, and that would not be constrained by these limitations. In fact, I decided to do that when I saw how much custom marshaller code that I had that was just doing very trivial things. So looking at the package, it's pretty big, but it's actually, once you find your way around, it's pretty easy to get things done. So what do you look for? If you're looking for changing encoders, you'll go find the new type encoder function. That is essentially like a roadmap for the encoding side of the package. It mostly looks like this, just looks at the reflected kind of your input. So if it's a string, it will use the string encoder. If it's struct, it will use the struct encoder. It's pretty straightforward. Decoders, on the other hand, are phrased in terms of their JSON concepts. So if it's currently decoding an array, there will be an array method on decode state. So given that, let's look at something we can do pretty trivially. Decode state for decoding is kind of where every new feature that you might want to add would be based. I'll show that in a sec, but let's say that we don't want to spin up a new decoder every time that we want to just disallow unknown fields. We can create an unmarshal strict function that just sets as a bool disallow unknown fields. These are already fields that are in the existing struct. For encoding, it's a little bit different. There's an oncops, or encoding ops struct, that essentially it's the place that you would pass any kind of Boolean or other kind of configurable, since it's passed essentially to every piece of functionality in the encoder. So that's where we'll add a bunch of features. Let's see a practical example. Don't want to show that too quick. So who here has had the issue where you've seen a JSON null come out when you didn't bother to initialize your slice to a zero-length non-nil slice? Any hands? Yeah, that's a bit annoying. Also, who's seen a comment in the middle of code that's completely unrelated to JSON outputting that says, hey, we're doing this because like 3 directories over, we're going to output this into onto the wire in JSON form. So we can essentially modify our fork to handle this pretty gracefully. We can do that by adding a helper function that just sets a non-null property. And in terms of this input, let's say hypothetically we remembered to do this with S1, but we added an S2 field and forgot to do it for that. Having this extra feature means that no matter what, all of your maps and slices come out as braces and brackets. By the way, this is something you can do backwards compatibly. We'll show some stuff that actually breaks compatibility in a minute. So all this consists of is adding a new field to the encoder, creating a wrapper around it, and then within the encoder will essentially construct this oncops value that I mentioned before and pass it down to all of the helper methods. Essentially all you have to do, it's pretty simple. You find the place where it just checks if the value is nil, and instead you check your option, make sure that that's not flagged on, and thus it's guarded by that feature toggle. What about omit empty? This is what I usually spend my time writing custom marshallers for, is cases where you want an entire struct, for example, to disappear if it's empty. It's also something that's pretty easy to do. This also counts for times. If you happen to have a zero-valued, a zero-timed time, but it happens to be in a different time zone, this can be something that can get in your way as well. So, and you can look at the time type and see, it has an is0 method. Can we not just use that? Well, with a few tweaks, we can. What this pretty much comes down to is there is one function that encoding uses to determine if something is zero-ish. That's isEmptyValue. So this pretty much just consists of adding support for checking if an is0 method is present on the value, if so, utilizing that alone, adding some like reflected deep equality checking. This could be optimized, yes. And if you want to, you can also take out all the redundant type-specific checking at that point, because it's unneeded with deep equal. And let's see. Should have an example here. Okay, so in this case, we've got a struct with an array of one item. We've got a time type that has an is0 method. The old version will output all of that. You can see with just the old time zone. And with the change, we effectively get an empty object as we'd like. And since I'm low on time, I'm going to do some Brad Fitzpatrick style slide skipping. And some other fun things you can do if you want to explore this. You could have field name rewriting, where you just say output snake case. So in case you forget to tag all of your structs, I've had this happen in production where I have 2 styles come through. This could cover you. You could also do more in the way of like dynamic unmarshalling, so you don't have to do as much with raw message, for example. And closing thoughts. Each of these really only took a few minutes in terms of like exploration and coding to proof of concept.
Thank you very much, Kevin.